Welcome to Module 3 of the CDOT Utilities Process Management course. In this module, we're going to examine how utilities impact the design phase, design scoping review, or DSR, to field inspection review, or FIR, which is also known as 0 to 30% design stage. So again, when we look at our utility engineering program project process graphic here, we are at this second stage where, again, we're at 0 to 30% design phase with a goal of quality level B at a 10% design goal. And the portion that applies to the law, or C.R.S. 9-1.5, 102, 6.8, is also known as the Subsurface Utility Engineering Required Project. So we'll investigate that a little bit more. So you recall in the last phase, we identified during the planning phase that we had a requirement under the law for a SU project, and that required a subsurface utility engineering notification. And now we're actually going to take that notification and move it into the required project and deliver that to our designers, again, by 10% design. So under the CDOT SU required project process, 0 to 30% design phase, again, our goal is quality level B deliverables by 10% design. During this design phase, scoping to FIR, field inspection review, the subsurface utility engineering required project is initiated, and we're going to go through in detail what that SU investigation means, following the American Society of Civil Engineering standards under the 38 section, the 3802. At this point, there is a new standard that will be coming out that will replace 3802, but the way the law is read, it says 38, so whatever the most current standard is the applicable standard that we have to implement and deliver. So through the SU quality level B investigation, we're looking for quite a thorough investigation as far as what we expect from our SU providers. And this is a deliverable that's typically not a CDOT in-house or something we can self-serve within our current establishment at CDOT. So it's mostly an outsourced type of deliverable from the subsurface utility engineer vendors. And again, if you remember back to our contracting discussions, we have those contracts in place for these services. And so that's where we rely on those. And again, there is the master SU scope of work that can be leveraged to obtain these services. Through the quality level B investigation, those SU vendors will utilize a standardized line work when depicting these utilities. They'll also provide justification notes on their quality level justification for the utilities. The law requires that the agency attempt to achieve quality level B on everything, but if we cannot, then the engineering charge or the SU vendor will then need to justify their quality levels based on justification notes and why quality level B was not able to be achieved in certain instances. So that's where when we kick the SU required project off, we're looking at these three things as far as deliverables within the SU package as we move forward. So again, the SU process, 0 to 10% design. The process overview, again, requires a SU notification to the one call center, and that's, again, a utility coordination /SU kind of joint effort. It could be the SUE notification or the utility coordination effort has already kicked off, and we do have some records from the utility companies. But the SUE notification itself must come from the engineer in charge of the project through the One Call Center as an official SUE notification. But that SUE, and that's their notice to the One Call Center that this project has been initiated, and then we'll move into the SUE required project. So the SUE pre-meeting, so we try to have a meeting with the SUE company, our utility coordination team, to make sure that and the utility owners, to make sure that we're all on the same page as far as the SUE deliverables and records and everything in order to initiate the investigation for the existing utilities. That quality level B investigation will then move forward with the SUE consultant. The SUE plan depiction requirements will be implemented and incorporated into the deliverables from the SUE company. Conflict analysis will then move forward with that SUE plan, and post SUE meeting will then kind of wrap up, and with utility coordination and the SUE vendor kind of looking through with the designers to look through and make sure everything that was expected in the scope of work from the SUE vendor has been covered. And if it hasn't been, then of course we send SUE companies back out to complete work that's either deficient or missing or extra work that we identified during this post SUE meeting. And so again, specifically at the SUE pre-meeting, we're looking at the scope of work in detail, the existing facilities, including the service laterals, any existing abandoned utilities, facilities that are out there, if we can identify those, or in Joe's case, he has a project where, abandoned facilities for a relocated line kind of falls into play here as well.
Right, that's a good point, Rob, where we have identified that intermediate pressure gas line will be lowered pre-project by a private utility company, and their intent to abandon the facility in place in our alignment. We really use this as an opportunity to have them pull the abandoned line, so we don't have a line that remains in our right-of-way at a substandard depth, and B, it doesn't become an obstacle during construction or an obstacle for future utilities. So abandoned facilities in two respects.
Good point. And those abandoned facilities can be problematic if they're identified, during the SUE process, when a contractor is out there on site and they're working and they come across one of these facilities. If they're not shown on the plans, then it can really put a stop to a project while they try to investigate what actually is going on. So it is an important piece of the SUE requirements. Also, the size of all the lines, the type of material, any overhead utilities, and where those points of overhead go underground, and how many utilities are in inventory of the overhead lines, including the number of different utilities on those overhead lines. For example, you could have an overhead line that's owned by a power company, and they've allowed a telecom or a cable company to come in and also install utilities on their overhead lines. And that happens quite often. So you could have 2, maybe 3 or 4 different utilities on an overhead line. So even though we talk subsurface utility engineering, at some point they could go overhead and aerial, and so but at some point they'll probably go back down underground as well. So it's really tying the two together because they do work in concert together when it comes to overhead to underground. And then really looking at the quality level B investigation by the SUE consultant. A term that we really want to emphasize when it comes to this ASC 38 standard is the term designating, because I think most people are familiar with utilities and marks on the ground or paint on the ground as historically been referred to as locating. And locating is actually a different process when it comes to subsurface utility engineering. So changing our mindset or our terminology is key when it comes to understanding some of the new terms under subsurface utility engineering. So if you hear designating by a SU consultant or region utility program manager, that's the process of identifying existing utilities and marking them on the ground, and then the process of surveying and working on that. So designating is that process. It's also the process of achieving quality level B. Again, that's the objective, and that's not only a standard, but per our legislative rules. So designating includes utility base maps, and then also the microstation levels that will be delivered in a design.dgn file. So this is the consultant delivering the quality level B investigation to CDOT, to a project manager, for inclusion in the design. So also based on the anticipated extent of the project, is where this QL-B investigation will lie. And then the definition here at the bottom of quality level B is very important. So I'll just go ahead and read it, and then we can chat about it a little bit. But quality level B is a value assigned to a utility segment or subsurface utility feature whose existence and position are based upon geophysical methods combined with professional judgment, and whose location is tied to the project survey datum. And so if we, I know it's a lot to take in, but if we kind of dissect that, a value assigned to a utility segment. So it doesn't have to be an entire existing utility line. So if it's a water line and you know that you need to have a higher dependency of the accuracy and location of that water line, you need that for your design, then quality level B should be scoped for that line segment. Maybe it's only 50 feet of that line through your project, and there's 500 feet of that line that's within the project limits, but only 50 feet of it is within maybe a new storm drain system that's going in. So you want to identify that in the scope of work that I need this water line, quality level B. Outside of that, it could be C or D, and that could easily be investigated by the SU company. And so,
and that's a good point. You have the quality level B. One thing I didn't see in this definition, but we've certainly talked about in the past, is a quality level B mark is reproducible, meaning using the same means and methods you use to initiate that mark and is reproducible if you use the same means and methods again. So the mark in the initial evaluation it can be reproduced over and over and over again using the same means and methods. There's not variation there, either horizontal or variation in that mark when you use true quality level B methods and methodologies.
Yeah, Joe, and part of that basis of being able to reproduce a line includes the use of geophysical methods combined with that professional judgment in order to establish that location. And we'll get into the geophysical methods here shortly, because that's a key component of the AFC 38 standards, and how SU vendors are use the tools that they have to establish that quality level B designation. So again, this is a part of this is utility coordination effort when it comes to setting up and working with the SU vendor to get the meetings established, and working with the SU vendor and on the scopes of work and expected limits and things like that. And then the SUE vendor will then take over on some of these items. So that's why this slide down below is both the utility coordination level effort and a SUE level effort. So methods of designating quality level B are identified here. This is really, when it comes to the active and passive part of transmission and receiver only type of frequencies that we're talking, but and we'll get into those in a little bit more detail. But the active side of things means you're actually providing a direct connection to a utility tracer wire or to the utility itself with an inductive coupling, or you're sending a charge down the utility if it's capable of being charged so that you could follow it from the surface and try to trace that location from the surface using certain frequencies to do that. Some utilities have a frequency that they emit passively, and they're not charged. They're just constantly on emitting a frequency like electricity and cathodic protection signals on gas lines and things like that, radio frequencies, metal detectors, and then some people are used to the old witching sticks, so to speak, and so some even have said that a passive signal could be from that as well. But the most used type of designation or quality level B signal tracing is an active transmitter and receiver, and those designating tools, along with the active portion, is included with the electromagnetic methods like we talked above, the active transmitter receiver. There's also other types of routers and sondes that can be inserted into a utility conduit or a pipe, and they can then be traced from the surface as they traverse through the pipe itself. Routers and sondes work really well in sewer lines and where you can gain access through a manhole and then trace those from the surface. There are other methods as well, like CCTVs that can go down in there and follow the line with a camera, and from the surface you can trace it and also see where laterals take off. So there's a lot of good tools under the geophysical definition that fit here. Laser scanning is new and it's becoming more popular with scanning the inside of manholes. You can do that to obtain better invert values on your pipes where they flow in and flow out. You can use this laser scanner to get very accurate information from for major downs on that. Ground penetrating radar is evolving very rapidly with multi-channel radar that has moved into a much more advanced sector of the business where it can be used from the surface to penetrate down. It's like an X-ray machine going down and trying to figure out where trenches are or pipes are based on how the system is set up. And I have a graphic on the next slide. I'll show you kind of what that GPR signal looks like as they run across the ground. And then advanced geophysics like the multi-channel radar and electromagnetic 3161 equipment as well. So some of the range of location depends on type of conductor that they're looking at. So when the SUE companies are out trying to figure out what type of pipe, is it PVC, is it corrugated metal, is it ductile iron, there's many types of pipes that conduct better than some or others, and some they just don't conduct at all. So diameter of the pipe is definitely something that the SUE companies have to consider. Smaller is better than the larger pipes for whatever reason. Quality of ground at each end, the soil conditions is definitely a major player when it comes to ground penetrating radar. Colorado has a lot of clay in their soil, and that's really one of the problems that ground penetrating radar runs into, is that type of soil. Frequency of locator, when they're designating types of frequencies that they're using and the channels they're using, is a major component on how they trace these things accurately, because there is a tendency for other frequencies to bleed off onto their locating equipment, and it will give them a missed signal if they're not capable of checking and identifying that. So, and then power output, higher power means you get a better signal versus lower power. So this is truly just a SU function. No utility coordination at this point. Your SU consultant's really managing all of this and all of the equipment. It's just be aware that this is kind of the behind the scenes look at some of the equipment they use, and it's imperative to know what tools they have available. If you're trying to scope something, you may want to include one of these other tools or ask questions about, hey, is there another tool we could use to find something out on my project?
Right, and the ultimate goal is to produce a PE stamp set plans, and these PE stamp plans should essentially attempt to achieve the quality level B status unless a reasonable rationale by your licensed PE is given. Those methods of designating during investigation include the active systems here, which is preferred, but also the passive ones Rob ran through earlier.
Very good, Joe. So when we continue to look at SU investigation, quality level B in particular, determining depth is always a question we get, and trying to establish a depth on a utility. Quality level B, again, is Joe alluded to the reproducible horizontal accuracy, and the depiction and dependability of that quality level when it's assigned to it is really a horizontal position only. But there is an opportunity during this process that the depth can be captured, but we want to make sure that everybody understands that the type of equipment being used and the people that are using the equipment and how they're trained can vary greatly, and the depth will tend to reflect that. So, determining depth with this type of equipment, especially with electromagnetic locators like the one shown on the bottom right, has to be determined by the SU vendor, and it can be requested that they provide those depths in the scope of work. So I would suggest that we consider having depths provided during quality level B investigations if we're trying to get an approximate location on the vertical to help us with some early design information. So the clear signal, the clearer the signal, the more accurate the depth. So any noise in the signal can definitely disrupt the depth and the calculation of depth. None of them are 100% accurate. Again, signal peaking above like a water main in this bottom left corner of the slide with no interference, you're going to see just a nice wavelength coming off of that utility, and with no interference. But and there are cases where there's a dot there that's BT labeled, and that's buried telephone. There are cases when the signal can bleed over to that buried telephone line when you're trying to trace a water line, and then you end up with a signal that gets confused, and then depending on the person running the equipment, they could end up calling that buried telephone line the water line by mistake. And so we have seen some of that. So if you see a water line that starts in one direction and ends up on top of the telephone line, there may be cause for concern. But that's just kind of how the equipment is working. And again, the SUE vendors are supposed to be monitoring those frequencies and being able to designate when things are bleeding off. And then electronic depth estimation, there's just a graphic there on how the machine is thinking and conducting the math behind it. Not that you need to know the math, just know that how the signal is being emitted and how the equipment from the surface is trying to determine that depth when it's recorded, when it's finally, say, okay, this is the spot, this is where it is, and then they record it, it's going to use that to capture the depth. And then 3D utility depths down on the bottom right, again, with the electromagnetic depth reading, that's what we just looked at. Ground penetrating radar is that red, green, yellow graphic over to the right. And there's some marks that are kind of going in a V direction and a downward direction. That's where the ground penetrating radar has identified a trench or a utility, and then from the surface down, they can kind of see where that's at depth-wise. But again, that takes one of the geophysical and utility engineering specialists in order to read that and determine what, interpolate what that means. But eventually, we can always come back and use a quality level A test hole to verify ultimately what the depth really is. And that's the best way and really the only way to determine the actual depth of the utility is to open it up and see it and collect it. And then access through manholes and vaults and boxes. Obviously, you can gain depth readings from there because you have visual where you can see into those facilities, and then move forward from there. And then so again, this is all information that we try to spec out. We try to have our contractors and others, especially our SUE vendors, collecting some of this information, but then we also want to make sure that within our standards construction specs that contractors know where this information came from, what the reliability is, and if there's any considerations that they should be making when it comes to relying on this information is very important, because we certainly don't want a contractor to take this and rely on it and then have an issue with hitting a facility because they thought the depth was 100% accurate and they didn't take the time to actually open it up or pothole or test hole themselves. And so that's where that last bullet point kind of comes into play. Again, this is a SUE function, no real coordination effort that's involved in this segment. One of the big portions of SUE that we want to emphasize when it comes to data collection is the attribute information that comes with the SUE investigations. And attribute, define characteristic of utility feature or utility segment. Examples of utility attributes include the utility owner, utility type, size and shape. Is it encased? What's the configuration? Is it operational or is it out of service? Outside diameter, so that we can verify where the true top of the utility is at based on where it was measured to. So there's a lot of that information that we're trying to gather. Non-encased multi-conduit systems, is it, is it six-inch conduits, or is it, 12 2-inch conduits, whatever it might be. There's definitely a case for why we need to know that information. I've definitely seen problems. We ran into problems where we didn't know, and we'll show one, I think, an example later on during construction where we had information on the utility, but we didn't have the complete record of the multi-conduit and how it was encased in concrete, and how that ended up causing us a redesign and a delay during construction. But we'll talk about that a little bit later. age, date of installation, so we have a record of how long the utility's been in there and what the condition might be based on service life. So again, all these attributes are extremely important to try and capture as we move forward in the SUE process and then further into the conflict analysis process and other means and methods.
Right, and those attributes it's incumbent on your SUE provider to identify as many of those attributes as possible, and it's imperative that we convey that to them early on in the process. If a line is encased or if it's not encased and we have to have it moved, it impacts schedule, it impacts ease of relocation. Type of material, does it have asbestos in it? Does that require another whole nother methodology of removing asbestos pipe out of your project, and you have to plan for that during construction. So knowing these attributes is important, and identifying them early and giving that expectation to your SUE provider is certainly an essential component of a SUE investigation.
Yeah, agreed. So moving on to more of the SUE deliverables that we see coming from the investigation includes example number 1, upper left. This, is a good example of the CAD output that comes from designating the utilities and showing the quality levels, the types of utilities that are there, the owner. So there is a lot of information that comes with the world of subsurface utility engineering, and so this is important to designers. Also, as it moves to construction, it's also important to the contractors to know what facilities are out there, what the sizes are, who the owner is, all that good information. But also our designers, as they learn what these quality levels mean, and then what the notes and the attributes that are being identified on this plan are very important. And an example of that is number 2, which is a real project of Joe's. And Joe, maybe you want to elaborate on that project, on the deliverables and how that is working.
Yeah, so this was the project that we went through the entire process of going through a SUE investigation, identifying certainly conflict points. As you can see, the multicolored bubbles indicating not only what the utility is, but the conflict number. So the yellowish bubbles, the mustard color, you can see gas conflicts, G10, G13, G14, corresponding to a conflict matrix, where we knew that we were putting in storm line and we had conflicts with gas at these locations. Red being electric, where our storm line had conflicts with inlets or other locations. And then brown being sewer, a sanitary line, and we had potential conflicts there. So going through this process helped us identify at least potential conflicts with what our design was, and identifying those early on allow us to either mitigate those through avoidance or certainly identify areas where we needed to go through and test hole and find out more information, what the depths of these lines were, get not only an XY value, but a Z value there. These are potential test hole locations. And within this project itself, I think we had 130, 140 different conflict points, and we had to decide where we wanted to test hole and where we didn't. But it's a really, really valuable tool for our designers, our storm system, and then the project designer to go and lay these out. Can we raise this line a little bit to avoid conflict? Can we not?
Agreed, Joe. And I think, as you noted, the quality levels are identified on those lines, those colored lines, which I'm sure helps with identifying the confidence level in that line work, whether it's quality level D or C or B or whatever it might be. But the it does help with conveying that to the designers, kind of what we're looking at when it comes to some of these utilities.
Well, and what I'm seeing here as well is, as we have another iteration of this drawing, G14 actually is a high pressure gas line. And it's not noted in this particular plan, but the next iteration, I think, did identify it as a high pressure gas line, and that line was then updated, the line type was updated to show that it was high pressure, and understanding that it's not simply, we can't move it as easily as we could a low pressure line, or have to accommodate it certainly during construction and issues around constructability of the road surface above it, compaction and avoidance issues. So
yeah,
the SU plan can tell you a lot.
Absolutely. And then when we move on to number 3 and we look at the example of a butterfly diagram of a vault. And so this is something that we haven't always had at CDOT, where we've included detailed drawings of each wall of the vault, so that you have a conduit count coming in from all sides of the vault, what it looks like, and coming in and going out. So this is a great example of being able to detail the vault out, the size of the vault, because a lot of times in the past, our CDOT CAD files would show a small box, a square, a rectangle as the vault, but it didn't really scale it to size, and it didn't have the level of detail that this diagram had when it came to the number of conduits going in and out and who owns them and things like that. So this is a change, and really a change for the better when it comes to additional diagrams and reporting of utilities, and this can also be detailed into the plans, with additional line work or notes or both. So I know we're spending a lot of time on quality level B deliverables, but it is important to understand how much information is being returned from the SU providers once they get started at 0% design, and how much effort they're going through to deliver all of this by 10% to our project management team, our design team, our utility, region utility program managers. And so, at 10% design, this is the package that you would expect to see coming in, which includes a SU report, which very similar to a geotech report. It's the who, what, and where, how we did things, a type of report. It's really the details on how everything was established, what equipment they used, how they ended up with a quality level B line for a certain segment, and maybe a quality level D for another segment. So it's really their justification and the details of how they did their work. And it's very helpful in seeing these reports, and it does help explain certain things, why they went certain ways with their investigation, or what were the hurdles that they experienced through that. And then in some cases, utility conflict matrix can be scoped and built from this data by the SU vendor. Test hole data sheets, you'll see pictures up there where you can see actually see the utility in the hole, and then they document. To the left, they have a record where they document the size, the type, the depth, and all that information in the test hole data sheets, which then can migrate over to the utility conflict matrix at some point as well. This is all stamped and sealed plan set deliverables. So the existing utility plans are stamped, the SU report is stamped, things like that. And then finally, a CAD file output that can be used and is used for referencing into the design files, and then leveraged again from the designer's perspective. They have a CAD deliverable with the quality levels that match the paper copy or the stamped certified plan set. So that's where these are transferred over to the design files at this point for reference, and then included and leveraged with the designer in mind you know, having the experience to look at those quality levels, ask questions about facilities if need be with their design. So there's a lot that can be done after 10% to help help the designers with this. So from 10 to 30%, again, I touched on this just a little bit, but you know, 10% design is underway. We have our designers looking at, you know, their design from the roadway side of things. Maybe it's the hydraulics engineers working as well with the designers, looking at new hydraulics that are going in. But they're continuing to look at these things, and when we expect to have our designers from 10 to 30% design look at really a three-phase action approach. And you know, the first and probably the most important and the simplest path for the designers to get their projects out the door and to add is to try and avoid the utility conflicts and leverage the SUE data to try and do that. So, you know, when we emphasize to the designers, you know, really try to use that data that you're receiving from the SUE vendors to look at a no conflict. That way you have less delays, less cost overruns related to utilities in the construction phase. You have less redesigns required because of the avoidance later on. So if you start out early avoiding things, then it just moves from 30% to 100% design much quicker.
And this may be as simple as, once you have good SUE data, once you know the X, Y, and potentially Z of the utilities that exist within the ground, avoidance may be raising or lowering your storm drain slightly to avoid conflicts, which would require a third-party entity to come into your project and relocate during construction, or your own design team redesigning a water line and then putting that work, you know, that work on your contractor to move it during construction. So avoidance is, if you eliminate those conflicts early on, as Rob said, it is the simplest path to clearance, and it's the simplest path for construction as well. If you don't have conflicts, you're well ahead of the game.
You are. And this is, I wanted to point out, but this is a utility coordination effort at this point. So the SUE data has been provided to the designer. It's also been provided to the utility coordination team, and that could just be the region utility program manager and their staff, or it could be a consultant that's been hired by the region utility program manager to manage this portion. But this is where utility coordination back and forth between the designer, the utility company, what can be avoided, what can't be, you know. So it's really a discussion and a kind of a problem-solving technique going on between the design staff, and that design staff could be internal or external as well. So it's really looking at, okay, we're at 10% design. We have this idea around the new infrastructure, new CDOT project facilities going in, but we do know there's something there when it comes to the utilities. So then it becomes that coordination effort to try and resolve it. And can we avoid it? If not, then we'll kind of move into phase two, which is, can we accommodate the utility where it's at in some way, some fashion? You know, can we create minimal conflicts or delays with these cost overruns by adjusting it in place? Can we lower it, you know, during construction? Can our contractor do that work so that the utility company's contractor doesn't have to come in and do that? So there's some of these things that we want to look at. You know, is there a partial redesign to our project that could help alleviate some of the stress on the utility moves that potentially would come about if we didn't redesign? So, but we got to do a cost analysis on that too, you know. So are these redesigns going to be expensive versus the time it's going to take to coordinate and relocate a utility? Maybe in some cases it makes sense to leave it alone, but you know, again, every time we move up this avoidance, accommodate, or relocate list here, we end up with higher risk to the project being delayed, and you know, might take more time to get it out to add. So again, just trying to look at it as a phased approach here, and end up with some middle ground.
Yeah, and then one of the notes we have here is, you know, can we acquire a right-of-way as an accommodation technique? Are there other things that maybe aren't necessarily utility related that can help us accommodate our design? So it's not only just utilities, there are other opportunities there.
No, you're right. Some other examples, like your Edwards project, where they were able to notch out a foundation in order to accommodate the gas line where it was at. I had a project in Eagle a number of years ago where we did something very similar with a wall foundation, where we made an adjustment in the foundation to notch it up and around and go over the top of the gas line, which saved us a lot of time and cost, because the gas line came out of a permanent easement into our right of way, and that's where moving it would then required us to go out on the private property and relocate it, which would then have been a cost to CDOT. So there was a lot of reason why we tried to accommodate that particular utility, and I could give a lot more examples on a lot of the utilities that we've accommodated in place with some minor changes to the design. So again, if none of these, if avoidance and accommodation is just not going to work, we've gone through and we've exhausted all design theory, and we've just gone through everything we can to look at a design on our side, on the utility company side, and then all, you know, at the end we have to relocate a utility. That's fine too. We understand that relocations are a part of the business, and that's okay, you know, and we need to know and be able to convey that to utility companies that we have, you know, considered all other design phase options, and we've exhausted those. So now we're at the end here where we have to look at a relocation, and now let's look at scheduling and for design and construction of the facility and relocation, and we'll give you all the information that we have thus far, which is, you know, what our utility coordination team has worked on, what our SUE team has worked on and our designers and everything else, so that we can come up with the best alignment, so we have the least amount of impact during construction. So that's the goal with all of these. Would you agree?
Yeah, and you know, certainly relocating is the most challenging, but I also found that relocation is probably the most stressful as well. It's stressing the design team because they want answers. We need to know where we're going to put the new utility. Pre-construction, we want the utility out of the way prior to construction, which, you know, at that point we're reliant on third-party external stakeholders in most of the time, and we are relying on their schedule. So does it happen pre-construction, or do we have to now introduce this third party into the contractor's role and have him try to manage this third party entity to come in and relocate a line? So it's very stressful, and so relocation in my mind it's not that we can't avoid doing it, but it's certainly I'd like to look at it as the last result, you know. Yeah.
Last resort.
Yeah, the last resort to for a utility if we can avoid it or accommodate it in other ways.
Yes, very good message. And if we can, as an agency, look at these in detail as we walk through a project, I think, you know, we'll find a lot more success in delivering projects quicker and also during construction?
Yeah, I mean, I'm sure we all have examples of if we could just avoid relocating at-grade crossing or widening at-grade crossing, or doing things related to the railroad, which is considered a utility as well, or how much simpler the project would go if we would look at other options way earlier on in the design process.
Yeah, I agree. So between Collide Level B investigation and the current 30% design, we're working on establishing those conflicts, and we're taking that Collide Level B information, we're comparing it, proposed design, and as Joe mentioned in his I-70B example in the previous slides, that the plan sheets start to develop, like the one on the right, where you have the utilities showing in dark black there. The bold is the proposed storm drain that's being designed. And as those things, start to merge together, the conflicts really start to surface. So they're there. You can start seeing all the different colored flags, blue, red, brown, yellow. And so those are potential conflicts. And so that is what starts to unfold. And then, it's built into what we call a conflict matrix. And we use that to establish a spreadsheet type matrix where we can start looking at things in a lot more detail, location, station, who the utility is, and things like that. And then at that point, we definitely start to look at what the quality level A locates or test holes that we want to pursue as far as developing a test hole plan. It costs quite a bit of money to go out and daylight these utilities for quality level A. So we want to make sure we're identifying those with a lot of care, and that we know that we only need what we need, and we don't want to spend extra time and money on stuff we don't need. So again, this is a utility coordination effort on developing, discussing the proposed design with the designers and the region utility program manager, and everybody's looking at these things from utility coordination effort. But you're also leveraging SUE when it comes to engaging the SUE company for the test holes. And so there's a lot of utility coordination going on, but then it also starts to turn over into that SUE kind of second phase of SUE, where then they need to go back out and daylight these utilities at this point. So again, documenting these conflicts, this is just an example of the conflict matrix, and this is also a handout that we have for Module 3, handout number 2. It's the I-70B conflict matrix, and so this is something you can take a look at in more detail. I probably forgot to mention that we had a handout number 1 back on the previous slide for the utility plan, and developing that test hole, potential test hole sheet. So keep that in mind. Look at both of those. Module 3, handout 1, and handout 2. They work hand in hand together as far as the development process here. So your plan sheet and conflicts, and then that rolls into this spreadsheet type system, which is also very helpful in identifying the specific utility company, the type of facility and location, station offset, material type. Some of the other information is X, Y, and Z, or northern easting elevation that goes along with that. What the conflict is with the facility and the project, and then a resolution area with the utility company's buy-in on that side of it, So that's the utility coordination side of discussing this conflict matrix with the utility stakeholders, and then also the SUE company going out and investigating and collecting the positional data on it and providing that into the matrix as well. And so that's what we're talking about on the bullet points over on the left. The conflict discussion with the stakeholders. Should have a meeting with the SUE consultant and utility coordination. If included in the task order for the SUE consultants, not always that way, it's sometimes separate. But SUE consultant, utility providers, and CDOT should all be, looking at these conflicts, and they should be reviewing them and concurring that, we need to get this additional information in order to resolve these conflicts. And so, looking at what's found in the field, obviously, again, looking at the COI level B information, pointing out those conflicts, what the utility relocations are, and what they'd be anticipated in order to complete during a project like this. Are there any utility easements in the project area? Who's going to pay for the relocations is always important. I think we emphasized that early on, and now it's starting to really pinpoint down to the granular level of these utilities in this matrix. Okay, here's where it's at. Here's the problem. Is it in an easement? Are you eligible? Okay, if you are, then we have a lot more information on the specifics of the utility at this point to start really looking at moving it forward into an actual agreement. We have several agreements, and we'll get into those in a little more detail later. But the ICC, or Incurred Cost Contract, it's one. The Subsurface Utility Agreement, the Standard Utility Agreement, not Subsurface, Standard Utility Agreement, railroad contracts that we have in place, construction and maintenance agreements, and things like that, et cetera. So,
that conflict discussion with stakeholders, that can look like sending plans to them and have them go over the plan with a matrix, on the table, looking at it, comparing the two, or it can be a in-person or video conference call. Certainly, we've had in-person meetings where we have created a roll plot of the plan as shown in the previous slide, where it shows all the conflicts and comparing it to the conflict matrix and going through each and every conflict per provider and saying, this is what's happening here, and this is where we anticipate a conflict, or should we anticipate a conflict, and bringing in the providers by waves. Maybe the gas company comes in first and you talk to them, or then you bring in the water company and you talk to them about the potential conflicts there. But this is a really important step, and to document that step is also key for down the road when you want to reiterate that you've had these discussions before, and you still need those conflicts resolved.
Yeah, no, it's an excellent point. Excellent point, Joe. And as we approach, our 30% design, then we're starting to, at least draft a specification for these utility information, and a lot of what comes into this draft is based on the utility conflict matrix, and so we're starting to identify where those are at, pulling those into the utility contacts information portion of the spec. General notification requirements are starting to kind of come together as far as what we know at 30%. That could change, but at least you're starting to pull together a spec that is in draft form that can then, just be modified as things move forward in either the post 30% design, and then from the test tolling information could change some of that, but you have a good draft started, and at least a list of the utility providers and contact information is definitely important. So again, as we move out of the 0 to 30% design, in moving from module 3 into module 4. We will definitely investigate the 30 to 90% in our next module, and we'll get into more of the conflict resolution, the test hole information between there, and then we'll start into work plans and how we set up for final spec, and also how we leverage a lot of this data with utility coordination into agreements. And so there's a lot as we move out of this segment. But before we leave, I just wanted to emphasize some key points of our module. The goal in this phase between 0 and 30% design is to complete the quality level B investigation by 10% design. That no depth measurement is 100% accurate in this quality level B side of things, but there are possibilities to achieve depths. Just keep that in mind. And again, probably the most important is the avoid relocation or accommodate the utilities, or as Joe put it, the last resort, relocate those utilities. And so, very important that those key takeaways are part of this module. Joe, any closing thoughts? No. All right. Thank you, everyone.